Welcome back, dear students. So today's session we are going to discuss cooling system of IC engines. So already we have mentioned that an IC engine comprises of different kind of systems: cooling system, lubrication system, ignition system, fuel system. So a number of systems are there which together work for the smooth operation of IC engines. So in this we are focusing mainly on cooling system of IC engines. So before going to the working of cooling system of IC engine, first we must understand the requirement of cooling system. So what is the requirement of cooling system of an IC engine? What happens if there is no cooling system in an IC engine? Why it is so necessary to design a cooling system for an IC engine? So this is the cooling system of an figure of IC engine cooling system. So already we know that by Kelvin-Planck laws of second law of thermodynamics, if you want to produce work continuously in a cycle, you must reject some heat. So it is impossible for an engine or any device to produce work by absorbing heat only. So it has to reject some heat also. So that is the important statement of Kelvin-Planck law. So that means any engine will reject some heat depending upon the temperature which it's operating. And what happens if you are not removing this heat? So this around 25 to 35% of total heat generated is rejected in an IC engine. So this is an approximate percentage. So if the heat generated by burning the fuel, among that 25 to 35% is simply rejected. Only the remaining portion is converted for useful work. And what happens if you are not removing this heat? Temperature will increase. So you know that if heat is continuously rejected, and if you are not rejecting or removing the heat to the outside of the IC engine, its temperature will increase rapidly. So this will result, we know that the components of IC engine are made of different materials. Already we have discussed the piston is made of some aluminum alloy, cylinder is made of cast iron or some other metals, valve is made of some other alloy. So all the material of IC engine is made of some metallic components, and these materials will have some temperature that it can withstand. So every material is having some temperature with it can withstand, and if you reach beyond that temperature, it will harmfully affect the component. It will result in erosion of component, and even high temperature leads to the expansion of piston. That is another problem. Piston is made of aluminum alloy, so aluminum. So if the temperature increase beyond certain value, it will expand. So what will happen if this piston expanded? It will seize in the cylinder walls. That is known as the seizure of piston. So it will be locked in that position, which will, and the further movement of piston will be not possible. So that is known as the piston seizure. So that is another point. If temperature increase very high value, it will result in piston seizure. So that means cooling is very must, and improper cooling will adversely affect the components of IC engine. So this is the reason why we have to employ some cooling system for every IC engine. Then what are the classification of cooling system? So mainly we have only two classifications according to the fluid used for carrying heat. So in every cooling system we are using some sort of fluid for carrying the heat from the engine, and according to this fluid we are classified cooling system into two categories. First one is water cooling, which is also known as liquid cooling, in which the main coolant used is water or some water with some additives. And the second one is air cooling, where the fluid used for transferring heat from the engine is air. So this is the main two classification of IC engine cooling system: water cooling, or which is also known as liquid cooling, and air cooling. First we will discuss the water cooling of IC engines. So we will discuss the water cooling system. So in this method, the engine cylinder walls and heads are provided with cooling jackets. So if we are having a 4-cylinder engine, we will have 4 cooling jackets. If it's a 2-cylinder engine, we will have 2 cooling jackets. The cooling jacket is nothing but a passage through which the water will be circulated through the cylinder walls and head. So this is the figure of a water cooling system. So you have to draw this figure for the examination. A neat figure is to be drawn. And this is the cooling jacket we are talking about. This is a 4-cylinder engine. You can see 4 cylinders here, and each cylinder is surrounded by cooling jackets through which we will continuously circulate the cooling water. So that is the cooling jackets. And what is the liquid used? So mainly the heat is absorbed by this coolant, which is mainly water. So in liquid cooling system, the main coolant used is water with some additives, some antifreeze material like ethylene glycol. So it is not pure water. Some additives are to be added. So why we are adding these additives? We know that in some country or some part of India also, in winter conditions, the atmospheric temperature will be very less. Suppose we are using pure water only, water will freeze around 0 degree. So that means the engine will not work. If the cooling system stops its working, the engine will also not work. So to avoid that, we have to add some antifreeze material like ethylene glycol or some other material, which will reduce the freezing point to some minus 10 degree or minus 20 degree, etc. So that we can use this cooling system even at lower temperature than 0 degree. So that is why we are adding some additives to the water. So that is the coolant used, and it is continuously circulated through this system. And you can see, other than this cooling jacket, we are using a number of components. Mainly 4 components are used. So what are the 4 components here? Yes, the first component is a radiator. So you can see here, this one is a radiator, which is a major component of a liquid cooling system. And we have a pump here for circulating water. We have a fan also for the movement of air. And finally we have a thermostat here, which is a small valve. This one is known as a thermostat. So these 4 components are necessary for liquid cooling system. So you can see the water will be continuously circulated in this direction. You can see the arrow. So first the cold water is entering the engine cylinder jackets. So it will absorb heat from the engine. Now when it reaches here, it will become hot water. So the water, when entering to the cylinder in this direction, it will be cold water. But when it reaches here, it will absorb heat from the engine, it will become hot water. Now if we want to again use that water, we have to reduce the temperature to this cold water temperature. For that, we have to pass it through the radiator. So in radiator, this hot water transfers heat to the air. So that is why we are using a fan here. So air will be blown through these radiator tubes. So when moving from here to here, from the upper tank to the lower tank, the hot water become cold water by transferring heat to the air. So we are using air also for heat transfer, but the primary fluid is water or liquid, that is why it is known as a water cooling. But to cool this water we are using air. So when reaches here the lower tank, the water will become cold water and it will again pumped. So this is continuous. So we want these 4 components for the working of water cooling system. Now we will look at one by one how these components help to work. First one, we know the radiator is a major component. This is a radiator. Mostly you can identify the radiator in the front of a vehicle. You can see a number of tubes like this in a grill, in the back of the front grill. So radiator, what is a radiator? Radiator is mainly consists of a number of tubes. So the previous figure you can see that a number of tubes for the passage of water between an upper tank and lower tank. So all the radiator will have 2 tanks, mostly one upper tank and one lower tank. And in the upper tank it will be hot water coming from the engine, which moves through this a number of water tubes known as radiator tubes. But when reaching the lower tank, it will become cold water by transferring heat to the air. So this is some arrangement of these radiator tubes. This is the front view and this is the top view. So you can see here a number of tubes are arranged in the equal distance. And the function of radiator is to provide sufficient area to increase the heat transfer between coolant and air. So why we require radiator? We can simply pass hot water through a pipe, a single pipe, and pass air, but that case heat transfer will not be much. We know that the heat transfer, here the heat transfer is by convection. We have 3 modes of heat transfer: conduction, convection and radiation. So in radiator what happens is the convection heat transfer, that is heat is transferred from one fluid to another fluid. So the primary fluid is our coolant or water, which is coming from the engine, hot water, and this become cold water by transferring it to the air. So you can see here air flow is here, water flow is here, both the directions are given. So air flow is in this direction. So that means air flow is perpendicular to the water flow. This is front view, this is top view. So to increase the heat transfer, you have to increase the area. Then only we can fastly cool this hot water to cold water when it moves from upper tank to lower tank. For that is why we are providing a large number of tubes between the upper tank and lower tank of the radiator. And another thing is a number of thin sheets are also attached. So across this tube we can see a number of thin sheet known as fin. So it is called as a fin. A number of thin sheets are attached to the radiator tubes for further increasing the heat transfer. So we will discuss this fin in this air cooling system. So fins are also used for increasing the heat transfer by increasing the area. And they are made of brass. So we want a highly conductive material for the quick cooling of this coolant. For that we have to use brass, which is having a very high thermal conductivity. So the brass tubes and sheets are used for this purpose. So this is the function of radiator. And what is the function of pump? You can see here we are using a pump here. So its function is to circulation of the coolant. So we want to continuously circulate cold water to the engine, again it become hot here, so it is going to the radiator, then again it reaches here. So we want to maintain a continuous flow of water, so that is done by the pump. And mostly we are using centrifugal type pump for this purpose. So this is a typical water pump or centrifugal pump used for this water cooling system. It will be a small size pump. And where this power is driven, if you want to work a pump, you have to supply some power, because pump is a power consuming device. You have to supply some mechanical energy to the pump. It is driven directly from the crankshaft through a belt and pulley arrangement. We know that the engine is running means it will have crankshaft also rotating. So we will derive some power from this crankshaft for the working of this pump through some belt and pulley arrangement. So that is how this pump got the power. And the third component is a fan. Here you can see a fan. So the fan is fitted behind the radiator. So if the radiator is here, the fan is behind the radiator because we want to circulate the air perpendicular to the radiator tubes. So air is blown in this direction while the water is flowing in this direction through the tubes. So its function is to induce a flow of air through the radiator block. So if the fan is not used, the airflow will be very small by natural convection only. So to increase the heat transfer, we are again using a fan for forced circulation of air. And the fan is also driven by a belt from the engine crankshaft. So also it's like a pump. We want to derive for the driving of a fan, we require some power. So it is again derived from the engine crankshaft through a V-belt. And sometimes this pump and fan will be in the same shaft. So pump will be, instead of here, it will be somewhere here, so that these two can be connected by the same shaft. So in some engines, this pump and fan will be in the same shaft also. And the blades of fan are normally made from metal for some large engines, and for smaller engines can be made of nylon, plastic, etc. So this is a typical radiator fan in the water cooling system. And finally we have thermostat. It's a small valve here, situated here. What is the function of thermostat? So thermostat is where it is fitted. It is fitted between the coolant passage of cylinder head and the upper tank of radiator. So we can see here, this is the upper tank of radiator and this is the cylinder head. So it is situated in between the radiator and this cylinder jacket. The passage between the radiator upper head and the upper tank and this cylinder jacket or cylinder head. And its main function is in cold starting. So what do you mean by cold starting? Cold starting means we are not using an engine for a long period of time and we are starting the engine, we will face some difficulty, and that is known as cold starting, because the cold air will be trapped inside the engine. So it will feel some difficulty in starting the engine. So in that case, this thermostat, it's a valve, small valve, it should be in closed position so that it should restrict the circulation of coolant. So if you are in cold starting, what will happen? If you are circulating the coolant, the temperature will further reduce. So to avoid that, we want to stop the flow of water to the radiator and this system in cold starting. So that is done by the thermostat valve. And when it automatically opens when the temperature increases, and it allows the circulation of water. So once the cold starting is over, the engine starts working for some period of time, the temperature increases and it will automatically opens and it will allow the flow of water. So that means thermostat is nothing but a valve operated by the temperature difference. So if the temperature is high, it is in open position. The temperature is low, particular value, it will be in closed position. This is the actual figure of a thermostat. So it is also used in refrigerator. So many devices we are using the thermostat because it is a valve which works by temperature change. So this is the working of water cooling system. And we are going to air cooling system. So what is air cooling system? We are simply using air as the flow of fluid for carrying away the heat from the engine cylinder. So in air cooling system, the heat is carried by the air. So no water or liquid is used here. And mainly we can identify that it is applied in bike, smaller engines like motorbikes. We can see a number of fins. For in air cooling system, these fins are very much necessary. What is fins? Fins are a number of thin plates or smaller thin plates attached to the cylinder wall, made of mostly aluminum or highly thermal conductive material. And its function is already we have discussed the heat transfer. Here also the heat transfer is by convection. So convection heat transfer means we are transferring heat from one fluid to other. So we are transferring heat to the air outside from the gas inside the engine. And to increase the heat transfer by convection, we have to increase the surface area. And by attaching this fin, we are simply increasing the surface area of this system. So this is the fin in actual figure. You can see a number of fins are there in the engine cylinder, outside of the engine cylinder, made of aluminum almost or other some thermal conductivity, high thermal conductivity material. And we know that air cooling system is mainly applied in motorbikes, aircraft engine, etc., where there is a limitation to weight exists. So what is the peculiarity of motorbikes? Because motorbikes we are not having any space for liquid cooling or water cooling, because the engine itself is a smaller one. So we have to adopt for the air cooling system. And aircraft also, the increase in weight is not that much advisable. In that case also we will prefer this air cooling system. So that is the application of air cooling system. And these fins are not only applied in engine, it's applied in every field. We can see this is a computer processor cooling system. We can see it is inside a number of fins made of aluminum alloy or aluminum. Here also it's increase the heat transfer by convection by increasing the area. And we can see they are applied also in transformers. So fins are used in every system, mechanical system, electrical or electronic system, for increasing the heat transfer by convection. They are simply increasing the surface area of the system. Finally, we have to compare the air cooling system and water cooling system. Already we have studied this. So the first point is the air cooling system, we know it's simple, its design is very simple, no other special components are required, only some fins are required, and they are less costly. But on the other hand, water cooling system is very complicated, a number of components are there and they are costly also. And another point is the weight of the cooling system is very less. So in air cooling system, the weight of the cooling system is very less, while the liquid cooling system is considerably more. And the installation and maintenance are also very easy in air cooling system, while this maintenance, installation, etc. are very difficult in water cooling system. And another point is there is no danger of leakage or freezing of the coolant in air cooling system. In air cooling system we are simply using air, so we don't have to care about the leakage or some freezing problems, etc. But in water cooling or liquid cooling, there is a danger of leakage. So if somehow the cooling water is leaked, it will affect the performance, and also the freezing is also very much adversely affect the performance of water cooling system. But even though these are the advantages of air cooling system, all these are air cooling system advantages, but the disadvantage is the rate of heat transfer is very low, because we are using air as the main medium for heat transfer. And what is the importance of air is its density, thermal conductivity, etc. are very less than that of water. We know that the density of air is only 1 kilogram, around 1 kilogram per meter cube, whereas the density of water is 1000 kilogram per meter cube. So it is almost 1000 times more denser fluid compared to air, and also the thermoconductivity, transfer coefficient, etc. are very high for water compared to air. So the rate of heat transfer is very low in air cooling system. So we are not able to use it for larger engines and multi-cylinder engines. So almost all the heavy vehicle, car, etc. we are not able to use the air cooling system due to this reason. So on the other hand, the water cooling system, we have a high rate of heat transfer. So it can be employed for multi-cylinder engine and for larger engine. So this is the main advantage of water cooling system compared to air cooling system. So this is the overall comparison of these systems. So with this we are stopping this session. Thank you.